Hello viewers, now I shall discuss Module 47. This module deals with the topic Applications of Neoclassical Trade Models. Neoclassical trade theory provides the tools of analysis and studies the impact of trade in a more rigorous and less restrictive manner. The application of general equilibrium trade models and later refinement of these ideas constitute the basis of modern theory of trade. In order to get an overview of the application of general equilibrium trade models, we can consider Jones 1965 and Jones 1971 as benchmark models. Let us first consider Jones 1965 model. We can begin with the assumptions of this model. First, it is assumed in Jones 1965 model that the economy is a small open economy. That means this economy is a price taker in the international market. Secondly, it is assumed that there are two sectors in the economy and each sector produces one commodity. The two sectors are assumed to be agricultural sector and manufacturing sector. The agricultural sector produces agricultural products and the manufacturing sector produces manufacturing products. Now, the agricultural sector is assumed to be the exportable sector in the economy, whereas the manufacturing sector is assumed to be the import competing sector. And this sector is assumed to be protected by a tariff. Thirdly, it is assumed that there are two primary factors in the economy, labor and capital, and each sector produces its product with the help of these two primary factors. Next, it is assumed that factors are fully employed and they are perfectly mobile between the two sectors in the economy. Next, it is assumed that constant returns to scale is operative in the production processes of both the sectors with diminishing marginal productivity of variable factors. Now it is assumed in Jones 1965 model that the manufacturing sector is capital intensive than the agricultural sector. That means the capital labor ratio used in the manufacturing sector is greater than that is used in the agricultural sector. Again, it is assumed in Jones 1965 model that there is no factor intensity reversal as we find in Heckscher-Ohlin model. Finally, it is assumed that perfect competition prevails in both product and factor markets, similar to the assumption of Heckscher-Ohlin model. Now we can specify the equational structure of Jones 1965 model as is shown here. Here, the first two equations show the price system of the model. This equation shows the competitive equilibrium conditions for the two sectors. First equation is for the manufacturing sector. As perfect competition is assumed in the commodity market, price of the product is just equal to the average cost of production. Now, the manufacturing sector is the import competing sector and it is protected by a tariff. Therefore, here domestic price is equal to domestic price is PM, that is equal to PM star. PM star is the international price of the manufacturing sector into 1 plus T, where T is the rate of ad valorem tariff. And this is equal to R, small r is the price of capital into AKM. Now, AKM is the capital coefficient in manufacturing sector. That means capital required to produce 1 unit of capital in the manufacturing sector, plus W. W is the wage rate into ALM. ALM again is the labor coefficient in the manufacturing sector. That means labor hour required to produce 1 unit of manufacturing sector. So this implies the equality between price of the product with the average cost of production. Similarly, for agricultural sector, we can write PA, the price of agricultural sector is equal to R into AKA plus W into ALA. Now here you can see that the unit factor coefficients are functions of factor prices. As here we have assumed variable coefficient technology, so all the factor coefficients depend on factor prices. So they are functions of factor prices. Here the factors are labor and capital, so the factor prices are wage rate and rate of return on capital, that is R. Now I have already mentioned that manufacturing sector is protected by tariff. Here the tariff, form of tariff is ad valorem tariff. So PM, domestic price of manufacturing sector, is equal to PM star into 1 plus T, where PM star is the international price of the manufacturing sector and T stands for the rate of tariff. And PA is equal to PS star is equal to 1. That means here the agricultural sector has been assumed as numeraire and therefore its price has been set equal to 1. Next, equations 3 and 4 represent the full employment conditions for the factors. Here in equation 3 we see AKM into XM plus AK into XA is equal to K. K, capital K, stands for the capital endowment level in the economy. Now AKM into XM is capital that is required to produce output of manufacturing sector. So unit capital requirement is AKM, that is multiplied with the output level of manufacturing sector XM. So this is the total level of capital that is required to produce output in the manufacturing sector. Similarly, AKA into XA is the level of capital required to produce total output in the agricultural sector. AK is the unit capital requirement in agricultural sector multiplied with XA. XA is the output level of agricultural sector. So this product AKA and XA is the level of capital that is required to produce the output in the agricultural sector. And as we have assumed that there is no unemployment of any factor, so the entire capital endowment level is exhausted in the two production processes. So total amount of capital in manufacturing sector and total employment of capital in manufacturing sector plus total employment level of capital in agricultural sector is just equal to the capital endowment level in the economy. Similarly, in equation 4, we get the full employment condition for the labor factor. ALM into XM denotes the labor employment level in the manufacturing sector plus ALA into XA is the labor employment level in the agricultural sector. This is just equal to L, total labor endowment level in the economy. So total endowment level of labor is just exhausted in using in the two production processes. Now let us examine how the model can be solved. Here we see that in 4 equations there are 4 unknowns. Now what are those unknowns? They are the factor prices, that is W, R, and the output levels XA and XM. So 4 unknowns are W, R, XA, XM. Now from the first 2 equations we can solve for W and R because here we have 2 equations and there we have 2 unknowns. So we can solve for the 2 unknowns from these 2 equations. And from here it is clear that we can solve the values of the factor prices without the help of the output system. That means here the price system is independent of the output system. This is known as decomposable property. That means Jones 1965 model can be decomposed into 2 separate parts. Here these 2 parts are not linked. They are just completely separate. So Jones 1965 model satisfies the decomposability property. Now after knowing the factor prices, we can solve for the input-output coefficients because they are functions of factor prices. Now once input-output coefficients are known, we can solve for the unknown output levels XA and XM from equations 3 and 4. So in this way, we can solve for the 4 unknown variables from these 4 equations. This completes the working of the model. Now, we consider the price magnification effect for Jones 1965 model. Let us assume for simplicity that rate of tariff is 0 and therefore price of the manufacturing sector in domestic market and in international market will be same. And for simplicity, we also assume that price of the agricultural sector is not equal to 1. So PA, that is price of the agricultural product, is same in domestic market as well as in international market. Now if we take total differentiation of the price equation for manufacturing sector, then we get this expression. dPm is equal to AKM into dR plus ALM into dW plus R into dAKM plus W into dALM. Now we consider the production function for unit isoquant. Now what is unit isoquant? That is the isoquant that represents 1 unit of any output level. That means here we have considered the unit isoquant for sector M. That means this production function represents output level of 1 unit for the manufacturing sector. So the production function is 1 is equal to function of ALM, AKM. Taking total differentiation and putting the condition that F1 by F2 is equal to W by R, we get this R into dAKM plus W into dALM is equal to 0. This we get from the tangency condition between the factor price line and unit isoquant. At the tangency point, slope of the unit isoquant will be just equal to the slope of the factor price line. Now, slope of unit isoquant is F1 by F2 and slope of the factor price line is W by R. So, this we get from that tangency condition. F1 by F2 is equal to W by R, and by putting this value, we get this condition. This is envelope condition, which says R into dAKM plus W into dALM is equal to 0. Now we use this envelope condition and we rewrite previous expression 1.1 as this dPm is equal to AKM into dR plus ALM into dW. Now we use hat algebra. So using hat algebra, from this expression we get PM hat is equal to theta km into r hat plus theta lm into w hat, where z hat is dz by z, that represents rate of change. Now, what is theta? Theta ij represents distributive share of ith factor in jth sector. That means theta km represents distributive share of capital in sector M, and theta lm represents distributive share of labor in sector M. Now, for the agricultural sector also, following the same method, we get PA cap is equal to theta Ka into r hat plus theta La into w hat. Now, again theta K is the distributive share of capital in agricultural sector, whereas theta La is the distributive share of labor in agricultural sector. Now, it should be noted that under constant returns to scale, theta Lj plus theta Kj is equal to 1. That means distributive share of labor in manufacturing sector plus distributive share of capital in manufacturing sector will be 1. Similarly, distributive share of labor in agricultural sector plus distributive share of capital in agricultural sector will be 1. Now, here we can say that from equation 6, we see PM hat is weighted average of R hat and W hat, whereas from equation 7 it is clear PA hat is weighted average of R hat and W hat. Now we can use Cramer's rule to solve for the values of R hat and W hat from equations 6 and 7. Now we get the value of R hat like this, theta La into PM hat minus theta lm into PA hat whole divided by mod theta. Now what is mod theta? Mod theta is the determinant value of the coefficient. Here this is expressed like this: mod theta is equal to theta km into theta LA minus theta LM into theta K. Now if we solve for W hat, we get this expression theta km into PA hat minus theta Ka into PM hat whole divided by mod theta. Now what is the value of mod theta? In this model we have assumed that manufacturing sector is capital intensive. So AKM by ALM is greater than AKA by ALA. And we can say that if this is capital intensive in physical terms, it is also capital intensive in value terms. And under this condition, we find that mod theta is greater than 0. Now we subtract the value of R hat from W hat and putting the expressions of W hat and R hat, and by solving those expressions we get this: W hat minus R hat is equal to 1 by mod theta into PA hat minus PM hat. Now we just seen that mod theta is greater than 0. So here we see that if PA hat minus PM hat is greater than 0, then W hat minus R hat will be greater than 0. That means if PM hat is greater than PA hat, PM hat minus PA hat greater than 0 implies PM hat is greater than PA hat. That implies R hat will be greater than W hat. Now mod theta is greater than 0, fine, but this is also less than 1 because theta ij's are input coefficients. These are fractions. So mod theta is greater than 0 but less than 1. Therefore, from equation 11 we find that R hat minus W hat is greater than PM hat minus PA hat. That means when PM by PA increases, PM by PA is the relative price of the manufacturing product. If this increases, then R by W will increase. Not only that, it increases by a higher amount. So R by W increases by a magnified amount. This is price magnification effect. So ultimately we get R hat greater than PM hat, greater than PA hat, greater than W hat. This is the price magnification effect of Jones 1965 model. And it ultimately leads to Stolper-Samuelson theorem that we get from Heckscher-Ohlin model. Next we consider the output magnification effect in Jones 65 model. For that we first totally differentiate equation 3, that means the capital market full employment condition, and after some manipulation and using the concept of elasticity of substitution and envelope condition, we get this expression 12. That is lambda km into xm hat plus lambda k into xa hat is equal to k hat minus delta k into W hat minus R hat. Here delta has been considered in order to shorten the expression. Similarly, for labor market equilibrium condition, we get this expression after total differentiation and using the concepts of elasticity of substitution and envelope condition, equation 13. Here also we have considered one notation delta, and that has been considered in order to shorten the expression. Next, we solve for the values of xm hat and xa hat from equations 12 and 13 using Cramer's rule. And we get these expressions, and here you can notice that we have converted the expression in terms of commodity price changes. For that we have used the relation between factor price change and commodity price change, and the expression for xa hat is this. Next we have shown that the value of mod lambda is again greater than 0 because we have assumed manufacturing sector is capital intensive than the agricultural sector. Now, if we subtract the value of xa hat from xm hat, then we get this expression, and this has been shortened in this way. Xm hat minus xa hat is equal to k hat minus l hat by mod lambda plus delta k plus delta l by mod lambda into mod theta whole multiplied with pm hat minus pa hat. This is expression 17. Now, here we assume that only factor endowment levels are changing. Factor prices are not changing just because commodity prices are constant. So, we can rewrite equations 12 and 13 in this way, and after that we can solve for xm hat and xa hat from these two equations. And here we get that xm hat minus xa hat is equal to k hat minus l hat by mod lambda. Now, mod lambda is greater than 0 as manufacturing sector is capital intensive. So, when k hat is greater than l hat, xm hat is greater than xa hat. Now, k hat is the weighted average of xm hat and xa hat. So, k hat lies between xm hat and xa hat. Similarly, l hat is also weighted average of xm hat and xa hat. Therefore, for the condition k hat greater than l hat, we get xm hat is greater than k hat greater than l hat greater than xa hat. So, this represents the output magnification effect. That means if capital increases more than labor, then the capital intensive sector, the manufacturing sector, not only increases, it increases by a magnified amount. Now, if we assume L hat is equal to 0, that means there is no change in labor endowment level and only capital endowment level is increasing, then the capital intensive sector, that is manufacturing sector, will expand by a magnified amount and the labor intensive sector will contract. This is output magnification effect, and this ultimately leads to Rybczynski effect. Next, we consider Jones 1971 model. Here we again consider two sectors, manufacturing sector and agricultural sector. Now, there are three factors of production in this model. Capital is specific to manufacturing sector, whereas land is specific to agricultural sector. Labor factor is mobile between both manufacturing sector and agricultural sector. So, in this model, we have two specific factors and one mobile factor. Now, the equational structure of Jones 1971 model can be represented in this way. Here, in the price equation for manufacturing sector, we get the factors labor and capital, whereas in price equation for the agricultural sector, we find labor and land. Equations 23 and 24 represent the full employment conditions for the specific factors, and equation 25 represents the full employment condition for the mobile factor labor. Now, here in this model, we find that there are three unknown factor prices in two price equations. So, three unknown factor prices cannot be solved from the price system alone. In order to solve the values of factor prices, we need to take the help of output system. So, from here it is clear that Jones 1971 model does not satisfy the decomposable property. Now, with the help of the full employment condition for the mobile factor labor, we can solve for the three unknown factor prices, and after knowing the factor prices, we can determine the values of input-output coefficients, and ultimately we can determine the values of output levels of the two sectors. Next, we examine the validity of price magnification effect in Jones 1971 model. From the two price equations, taking total differentiation of those equations and after some modification, we find that the price magnification effect is valid for the specific factors only, but it is not valid for the mobile factor. The change in the price of the mobile factor is moderate, whereas change in the price of the specific factors is magnifying amount. So price magnification effect is reserved for the specific factors only, and that is not valid for the mobile factor. We see what happens if we consider the output magnification effect. Here we see that if the endowment level of any specific factor rises, then it is not necessarily that the output of that product which is intensive in that specific factor will rise by the magnified amount. Here we have considered k hat greater than 0, but for that we find that xm hat is less than k hat. So from here we see that output magnification effect is not valid in Jones 1971 model. It can be concluded that in Jones 1971 model, price magnification effect is valid only for the specific factors, whereas price magnification effect is not valid for the mobile factor. The output magnification effect in Jones 1971 model is not valid. Thank you.